And I'm going to do a Mark Frost and do my Sitecore selfie. Yes, yes. Well, dude! Sit. All right, ready? There you go. Perfect, okay. So this is JSS Immersion. So I'm Anastasiya. I'm the front-end evangelist for Sitecore. So what the heck is an evangelist? So basically, that's a really weird way of saying that I'm here for the JSS community. I'm here to support your success. So I answer a lot of questions. I write technical blog posts. I spend a lot of times in calls and answering questions and doing a lot of like supporty things. So if you want to chat about JSS, just come find me. I would love to talk about it. I love JavaScript. That's why I took this job. So I'm very passionate about it. So that's what I do. So when I took on this role, I already knew JavaScript, React, and Sitecore. But obviously, I needed to learn JSS. So today, I will talk about my experiences of learning JSS, and more interestingly, my experiences of integrating a handful of popular React libraries into my JSS sandbox. Third-party modules are a key benefit of working with such a popular open source framework like React. It had roughly 170 million downloads just in the past year. So it already has a really big community of devs behind it that are constantly building things and putting them on GitHub. And we can use those in our Sitecore implementations. So I found this quote on one of Alex Shiba's blogs. One of the primary goals of Sitecore JSS was to add a proper first-class interface for JavaScript devs and enable using modern JS tech to build websites and web apps powered by Sitecore Experience Platform. So when I talked to the JSS product team about what was the vision behind JSS, what they told me is that it wasn't about bringing in front-end devs and making them learn Sitecore. It was really about building a flexible API that empowers JavaScript devs so that they don't have to change how they code. If you're coming from the React world or the Vue world or the Angular world, whatever best practices you know from those worlds, you can continue doing those. So you bring those with you. Whatever patterns you already know, they're still applicable. However you're used to structuring your projects, that's still applicable. And I wanted to see for myself if that's really true. Can I really build a site without writing a single line of C# code or creating a single Sitecore items? So that's kind of one of the things I wanted to test out as I was building my sandbox. So what I did for my learning was I studied the documentation site for about 2 weeks. Like was my job for that time. And then I found these two videos really helpful. These were done by Rob Earlham. One is an overview of kind of the business value of JSS and what value it brings to your company. So if you're trying to convince your bosses to let you work with JSS, that's a really good one to watch. And the other one is a video of him going through the quick start and going through that CLI and building his first app and actually deploying it. So if you actually want to watch somebody do that, that's a really helpful one. So if you guys, I assume whoever's worked with JSS has gone through the quick start, so I won't spend too much time on that, but this is kind of what you get when you do that. And it comes with a style guide and some GraphQL pages. And what I just want to say is that don't ignore the style guide. Even though it's called the style guide, it's not like, like how to make your code be pretty. It's not that kind of a style guide. It's really like it teaches you how to work with the different Sitecore fields in JSS. It gives examples for how to work with GraphQL. It gives examples for how to work with the personalization API. So it's really the next necessary step for learning JSS. Okay. Oh, sorry. But of course, it's like all that style guide stuff is not necessary for production. So once you're done with your learning and you're ready to move on, it's necessary to strip all that out. So my next step was to get rid of the style guide boilerplate, to get rid of Bootstrap and remove it from my package.json, and to get rid of the hard-coded navigation. So what did that leave me? This beautiful empty page. So now what? We don't have drag and drop components to start with, like with some accelerators. So I have to start everything and build everything from scratch, right? Grid, navigation, metadata, or do I? With 170 million downloads in just 1 year, surely there should be some components I can reuse, right? So maybe it's not out of the box, but next to the box. So the next steps, I had to pick a use case for what to build in my sandbox. So I went with something that I've had to done in many past Sitecore implementations that required a lot of custom JavaScript, which was search pages. So I wanted to build event pages where the content author could manage Sitecore user events. So I wanted them to be able to have these event items in Sitecore, and they should be tagged with like location tags, which were reference fields, so not just simple string fields. And then I wanted to expose those on a search page. I wanted them to be filterable by keywords. I wanted the search components to be modular so the content author can control the layout. I wanted to have a dynamic navigation that's just generated based on your content tree. And then, of course, I wanted everything to be responsive and configurable by the content author. So this is the end product. So it loads, it's got animations. As you hover over stuff, it's got some micro interactions in there, which is good for your UI. You can click on it, and then it shows you more details about what you're looking at. And then there's a search where you can filter by keywords. Take a drink here. So we have a dynamic navigation that's generated from the content tree. We have a GraphQL-powered search box and search results, which are filtering to only show a specific Sitecore template. We have a background that's generated from some page-level theme fields. And then we have 2 instances of a header component, and they look different because the content author has configured them to look that way. So let's dig into the lessons I learned in building this sandbox. So the out-of-the-box React starter comes with a bunch of server-side scripts. Everything from a script that generates files for components to a script that launches a local server to run in disconnected mode. Kicking off these scripts mostly happens through npm scripts. So if you go to packages.json, you will see this script section here, which has all the commands that kick this off. So if you want to do any kind of customization, this is your starting point. You need to come here and see what is actually happening when you run a certain command. And that's how you can find how to start your customization. So for example, the command to generate the files for a custom component is JSS scaffold. So we can see here that JSS scaffold is calling a script called scaffold component.js. So by default, there's only there's a script, a string template for your new components. So all your new components look the same exact way. So what I wanted to do was give some options so that I could have a component that's a function or a class and control which one I'm scaffolding with some parameters. So what I did was, so once I found out what the entry point script was, I added a new file where I'm declaring my new templates. So instead of having, just a single string, now I have 2 strings. So if you want to have multiple templates, you can go nuts and create whatever you want. And here we see that in the original helper file, I'm pulling in my templates, and then I'm adding code that reads arguments from the command line. So then I'm parsing the arguments so I can see what the user has passed in. So I'm going to open up a command line and show examples of running both of these. So if I do JSS scaffold, and then I pass in just a sample name, and then a template flag. Can't see. There we go. I used RFC for React functional component and RCC for React class component. And then we'll see how the two of them are generated differently. So since JSS scaffold creates new files on the file system, it thereby makes some choices about your component structure. So what if you don't like the default structure? The default structure, whatever you pass in as the name of your component is used as the folder name, and then it has index.js. And this structure is important because it's used to generate the component factory. What the component factory is, it's a mapping from your React components to your renderings in Sitecore. So that's how the magic happens of bridging the two systems together. And the only, by default, what goes in the component factory is only, it looks for the index.js file, and then it finds the parent folder, and then whatever the name of that folder is, that's what goes in the component factory. So, but in React, your files don't have to be called index.js. Like, you can actually have like navigation.js, whatever.js. So if you don't want this really bulky folder structure, you might not like it, so you might want to change how the files are generated. So if you do that, just be aware that you might have to also update how the component factory is generated. Here's what the generated component factory looks like. So I do want to point out that one reason to just customize the generation of the component factory is if you're doing something like pulling components from somewhere other than the default location. For example, if you want to pull them from the node modules folder. Like in one of my blog posts, I wrote about how to package your JSS components into node modules. So then when you're importing that node module, you'll need to import them from the node modules folder. So that's a good use case for modifying where the component factory pulls the stuff from. One reason why I like how the default file structure works is because since it only makes the mapping for whatever like the index.js file is and then its parent folder, what that lets you do is if you need helper React classes to support your main component, you could organize them in the same folder. So for example, here I have a header container. And it has a helper file for background. So that's the thing that generates those animated triangles. So that won't be added to the factory. That won't be mapped to a Sitecore rendering. It's just there as a helper. The other thing is, since it's only looking into the components folder, it makes it really easy to add global utility classes. So here I added a folder called shared, and this is for just like for all my animations, for the card and the search results, the card flip that actually does the animations. So this stuff is used by multiple components, and it's very modular. It can be reused. It can be packaged into a node module, but that won't go into the component factory either. So I think the default structure is actually pretty useful. All right, so this is a summary of what we just went over. So next up, so for data modeling. So when working with JSS in disconnected code-first workflow, we need to define the schema for components and page routes. So in JSS, as opposed to working in Sitecore, we have to be more explicit about the role of the items that we declare. For example, in Sitecore, whether you're creating a template that's going to be a page or a data source, you create it in the same way, like you just create it from template. But in JSS, you use a different manifest function to create those two things. And that's so that when the items are imported from your JSS app into Sitecore, it knows where to put them and how to create them. So it needs to know what their purpose will be. So I won't go too much into depth about data modeling because I have a very in-depth blog post about this. So I didn't want to just be up here talking about what you guys can read about. But I wanted to mention this because it's a very important topic, and I wanted to give a couple of examples. So for example, manifest.addRoute is used to create routes and components, and manifest.content.addContent is used to create list items. And there's a handful of these manifest functions, and what I found really helpful in learning this is kind of visualizing where the item is going to go in the Sitecore tree, and then like identifying what the differences are in these items in my mind, what the differences in their purpose are, and then that's how I kind of broke up which manifest function they'll be used by. And then the other thing to note is that not all of those manifest functions you'll be calling yourself explicitly. A lot of them are called by those scripts that come with the out-of-the-box app, just based on the file conventions that you follow with the YAML and JSON files when you're building out your routes. All right, next is debugging. So I had a blog post about some errors I ran into when I moved on to connected mode, and in that I learned some debugging techniques. So the first one is how to set breakpoints so that you can see the state of your variables. I'm sure you'll know breakpoints. So there's an extension for VS Code called Chrome Debugger Extension. So you add that to your VS Code, then you add this exact config in that path there, .vscode/launch JSON, and then you just start adding breakpoints. Then you run JSS start, hit F5, boom. I could only get this to work in disconnected mode. So if anybody finds a way to do breakpoints in connected mode, please tell me. So all right, so once I go to events, then I'll hit the breakpoint in my header, and we can see that I have my variables there with. Yeah, so this is very useful for exploring the props that are passed into your component. So the next technique is, what are you doing? What's happening? Nope. All right, there's that. There's a slide missing. All right. No, it's just in the wrong order. Okay. Next technique is, so since I couldn't figure out a way to do those in connected mode, so we could just add log statements, and you don't have to rebuild or recompile or anything. They just start working. So it's quicker than doing that in C#. Yes. And finally, the other thing I recommend is everybody should be using a debugger tool for whatever front-end framework you're working with. So I use React DevTools. Vue has a really good one, and I assume Angular does too. So this shows you your entire nested component tree, and you can click on any component and see what props were passed into it and what the values are. This is really handy. So, all right. This is the console log thing. All right, sorry. So this was talking about console log. So what I was trying to show was that when you see an error happening, the console log is really useful for debugging build errors. So not just for connected mode, but build errors too. And what I recommend is if you see an error coming from JSS, what you can do is search for the actual error with VS Code search. If you can't find it, then by default, the settings in VS Code search disable searching in the node modules folder, which excludes all the JSS code. So make sure that's enabled. And then you'll be able to find where the error is coming from, and then you can add your log statements. All right. So those are the 3 debugging techniques I recommend. All right. So now, remember those next to the box libraries I mentioned earlier? So now I want to talk about those. So website pages are made up of 2 types of content: static content and content that changes based on the context of user events. So let's take a look at how JSS enables me to use open source React libraries to build better Sitecore renderings. So the first library I used was react-rebass. So this library rocks because it's very easy to install. It's just a single, npm install, and it's ready to be used. It has text, grid and flex, headings, button links. Basically, whatever static content you want to build on your site, this thing can cover it. It's small and responsive, and it takes in static data as props. And so your content authors are working with data, and then you have that data in fields. So that works really great because you have your content author configuration, you pass that in as props, like the example shows there. And then this thing changes how your components look. So you can apply this to responsive size, like if your content author wants to control how a component is sized based on different viewports, it's just an array of numbers. Basically, any CSS property you can think of, you can configure with this, and it provides theming capabilities, which I will show soon. So I used it for this header component. So what it looks like from the experience editor is like this. So there's fields for the content author to make some changes. So there's different sizes that the headers can be for mobile, desktop, and tablet. So this was my header definition in JSS, where it has the fields. And then from my YAML file, which represents the content author's data, you can see I gave it different sizes for desktop size, tablet size, mobile size. And then in my React component, I provided some defaults. And one other really cool thing here is that there's an element property. So have you ever built some stuff, and then later the SEO expert comes in and tells you, oh, this should be an H3 instead of an H2? Or, so you have to change your HTML. With this, the content author is able to control what the, if this header is an H1 or a div or whatever. So one of the properties that the react-rebass component takes is what the element to use to render it as. So the first header is an H1 and the second header is a div. This is how it looks in Experience Editor. And since some of those fields weren't WYSIWYG friendly, they're what I called invisible fields, but they need to be edited somehow. JSS handles this automatically for us because it injects this special ribbon button into all components that lets us edit all fields. If you have some kind of custom fields that aren't compatible with that pop-up, you can still write your own custom code for, like, if live mode, do this, if is page editing, do this. And the way you do that in JSS is you use that withSitecoreContext helper on the bottom there. So that's going to inject the SiteCoreContext into your component as a prop. And that lets you test what the current page state is, if you're currently editing or not. So then you can write custom code. Like here, I did that for the placeholder text for the input box, so that the content author can edit that when they're editing. So let's talk about theming. Enabling content authors to configure the look and feel of components increases their reusability. Theming is also very useful for enterprise clients who need to manage multiple brand sites, but want a similar overall layout. A theme is brand colors, fonts and text sizes, breakpoints, white space. I used a library called styled components for my theming. So this is, you might have heard this as CSS in JS, which is a little controversial. I really like it. So this lets you write CSS on a component level. And the reason I think it's really good is because so your CSS gets compiled with your JavaScript. On the front end, what happens is it generates CSS classes and sticks them onto your DOM elements, and then it creates a style sheet. And it only injects the styles that are actually used on your page, and you can combine this with code splitting. So you don't need to have your giant main.scss that imports all of your Sass files and always dump all your Sass onto every page. You only have the Sass that's used. And then I know a lot of times when you want to get rid of some CSS that you think is obsolete, but you don't know what that might break. So this eliminates that problem. It's a lot easier to maintain, and it makes components more modular because you have the CSS for the component right there. And as the previous example, this takes static props and it converts them to CSS, so you can let your content authors manage the look and feel. So this library comes with a theme provider, which needs to be injected globally. So I put it in the layout. So you kind of wrap your whole app with this, and the layout provider takes some props. It takes a theme as props, and the theme is a JSON data of colors, breakpoints. There's more in the documentation, but that's what I used in my example. So in my case, the colors are coming from Sitecore fields, so I'm letting the content author control the brand colors. And this is how they're consumed in my React components. So in my header triangles, I can just say the color name, since react-rebass understands theming, so it will know that, hey, these are not actual CSS colors, let me go look for them in the theme. And then when I'm writing my CSS, I can use that function syntax there to go grab the theme color. So my theme colors are used in the header and also in the search result cards. So if the content author changes something, it's changed globally. I should have brought water instead of coffee. It's not good for dry mouth. So the next library I'll show is React Spring, and this is what I use for animations. This thing is cross-platform. It's even supported in React Native. And it supports props, render props, and hooks. So they're really actively working on it and really staying on top with the latest React changes. The animations are very natural looking. So like any kind of micro interactions that you want to do for your front end, I really recommend this framework. So I use this in my the flipping of the cards. So the content author would specify which card they want to use for the front and the back, and of course the data is coming from the event items, and then I just pass in those cards into the front prop and the back prop, and then this framework handles the animation. So we went over the withSitecoreContext to get access to the SiteCoreContext, and then those libraries. And of course, their documentation sites are amazing if you guys want to learn more. So next we'll talk about dynamic content, so stuff that changes with user interaction. So when I started working with my sandbox, I didn't have access to all the GraphQL queries in GraphQL. I had to add some extra configuration. So just check if you don't see like access to the search query to filter your GraphQL items, make sure you have all these queries in your config. Yeah. So I'm just gonna show a demo of what I had to do to build out the query that gave me my search results with filtering on the event page type, and then we'll talk about. Yeah. All right. So starting off with the basic item query, which so when you're using this graphical interface, it shows you the documentation on the right. So this is really cool because you can just see what arguments are required. So for example, this one, it takes path, which is an item path or an ID. Sorry, let's restart. Okay, I won't do that again. It takes an item path or an ID. So the documentation is right there in the graphical interface. And then it shows you all the possible fields that you can get back from the query. So I'm just getting the name, path, and URL. And then you can also click into the complex fields. So for example, the template name. So for template, I have to write the object structure to really pull out its fields. And then we can also grab all of the fields on an item, but I'm looking in the documentation to see how to do that. So the fields query has an argument called ownFields. So if this is true, then it will only get the fields on that particular template and not any inherited fields. All right, so the root item did not have any fields on it. So I went ahead and jumped into one of the event items. So we can see now how I can pull the data for a specific item if I know its path. I'm not getting the page title field here since that is inherited from another template. So I can actually get a field directly by its name. But we can see in the results that it's just called field. There's nothing calling it page title. So what I can do is come back and specify what this should be called in the results. This is called aliasing. So when I'm writing my GraphQL query, I can actually tell it what to make the results look like. So now let's get into the searching. So when I start writing search, if I click control and then click on the search, that's how I pull up the documentation. So it tells me all the available arguments right there. So one of the arguments is the root item. And then I can give it fields to filter on. So my fields that I will use is the template, since I only want to see event pages. So note here that to filter by template, even though on the right, when it showed the fields, when it showed me the results for template, the template field name was called template, but in my search, I have to call it _template name. So it took me a little while to figure out how to search by template because of that difference. So what I had to do was, I decompiled the search class in GraphQL and figured out what the C# content search item result type was and looked at all the properties on it. So if you need to find additional fields to search by, that's what I recommend you do. So from the documentation, I know what the structure of the results will be. So I can tell my query what exactly to give me. And all right, so now I have my search results for my event pages. So you can see that in my results, I have items. And in my first query, I also had items, type item. So what I can do is pull out, since I'm reusing that segment, I can pull it out into what's called a fragment so that I don't have to keep repeating the same query over and over again. So if I pull out just that item part, and then I do what's called spreading it into those initial two queries. So what I've ended up now is a single query, a single call to the server that's pulling all the information for the root page and filtering for my event pages by keyword, and only giving me the precise field I've asked for in the format I've asked for, just in one call. So if we look at the results, the fields on my event pages, they're not all just simple string fields. Some of them are reference fields, like the location and the image. So how do we get those in usable format? So if I do control-click on fields to see the documentation for that, I will see that this returns a item field type. And then if I scroll down, I see that there's multiple implementations of this class. So what we can do is actually cast this to the right type, just like you would do in C#. So for my location tags, I'm going to cast this to a reference field, which then lets me get, here I went into the documentation and reference field, and this lets me pull out the target item. This is very similar to working with a reference field in C#. And then from there, since target item is an item, I can spread my item fragment. So there's our locations, and now we actually have the proper location name that I can use in my search result card. We probably don't need the fields on the list items, so that's why I went ahead and got rid of the spread and used an alias instead to give me field name. All right, so now we have our location. And then we can do the same technique for images. So if I go back to the implementations of item fields and then go into image fields, I see that it has an alt and a source property on it. So yeah. You get the idea. So this is the lessons learned. So I use the search query for the filtering. So check the implementation of the search results is sitecore.contentsearch.iSearch results. So that's how I found out what to use to get the template filtering. And you can use the spread operator to spread your fragments to make them reusable. Aliases are available to specify exactly what the results should look like. And then you can cast your item field to other field types. All right, so how is this used, the search used in my app? So I use the react-context API. So context provides a way to pass data through the component tree without having to pass down props manually. So you basically have to have a single context, a single point of truth at the top level of all of the components that use your context. And then they will have, you can have as many contexts as you want. There's no performance hit in having multiple contexts. They will keep track of the global data. What happens is whenever that global data changes, all the consumers of your context are reloaded. So if there are any performance implications, it's only when there are a large number of consumers, though the authors of the React library say it will really take a lot to have a big impact. So like Facebook style a lot of stuff changing. So I think for all the stuff I've seen in Sitecore, it shouldn't have a huge impact. So if I go to my header component, it's wrapped in a search container. So my search, I'm sorry, not my header component. The whole thing is wrapped in a search container, and that's so that the content author is free to move the search components around however he wants. So if I inspect in React DevTools, there's where the search provider is, and if I click on it, I see how the search results are being injected as props. So these results are then available to all the consumers of the context. So here's the search provider, which is in that search container. And what it has is, it has the state here, which keeps tracks of the results and the query and the total count. And it exposes some global functions like perform search and update search query. So whoever is consuming this context has access to these functions as well. And here's where our GraphQL query lives. So if I go to my search results component, here's how a consumer looks, and they get the context injected. So it's simply a matter of mapping over the results. So anytime the results change, this will get re-rendered automatically. So this is a React feature. All right, moving on quickly. GraphQL, there's one other feature of GraphQL I want to point out. I know I'm almost at the end. So that is the ability to do GraphQL at the template level. So when you're calling manifest.add component, you can specify a GraphQL query. So this will this will inject data into the layout service, and so this will be, you will get the result of this query instead of your fields. So this is what I used to generate my navigation. So yeah. And if you're working in connected mode, you have access to the same feature versus via the component GraphQL query field on your rendering definition item. So that's the final lesson learned. And one final lesson learned is that when you run JSS deploy and JSS start, my computer gets really hot, and my cat likes that. This is my blog, which has more lessons learned, and that's the GitHub for all the code that I showed today. I will make these slides available and tweet about them. So follow me on Twitter for JSS updates from Sitecore, from the JSS team. And yeah.
So we are a little bit over time, but I think we should have at least a couple of minutes for some questions.
You can feel free also to grab me afterwards.
Yeah, but let's, and you also have something you can
Oh,
pass
and
on.
Come get stickers, JSS stickers.
Yes, so 2 questions. Any questions? Or would you rather grab her afterwards? Oh, sorry, hashtag me too. Come ask her a question.
Very nice presentation, by the way.
Thank you.
Would it be easy to have GraphQL work in a way that is disconnected? Like, for example, I don't know, to mock it up somehow and grab data from the mock and then put it inside of the...
It's possible to mock it. I haven't tried that, so I don't know how easy it is. You won't, like, it's not the same. Like, you won't be getting data from Sitecore. There are libraries available to mock it. You should do it and blog about it.
A last question?
All right.
Let's have a hand of applause to her.